Chapter 8.1, inverse trig functions. So f prime of f of x, oh sorry, not prime, this is a different class, f of -1. So this is the same as saying f inverse. So f with a -1 on it of the irregular f of x will always equal will equal just the x, whatever argument is in here. So if it's 2, then it'd be 2, right? In general, it's just an x. But this is only true for every x in the domain of f. Now the other way, f of f inverse is equal to x for every x in the domain of f inverse. So basically they cancel depending on the one that's inside. So the one inside here, that's the domain we care about. Okay. And here's a definition of the trig inverses, the original 3. The inverse sine function. So that is defined as, so if you had the original, let's say y equal to sine inverse, right? So meaning the inverse sine. So y is equal to sine inverse of x if and only if x is equal to sine y. So that's the definition. So you can change back and forward. So if you have the inverse, you can change to this. Okay. They give you the definitions for cosine and tangent. Inverse cosine function. Y is equal to cosine inverse of x. I'm going to put IFF for if and only if. Right here in the notes, FF. X is equal to cosine y. So basically, you can convert back and forward. Now for tangent. Same deal here. Y is equal to tan inverse of x. If and only if x is equal to tangent of y. Oh, I forgot something. Shoot, let me see. Dang.
What is above that sin in the cosine? What is that? Like quotation marks on the definition part?
Quotation marks. Oh yeah, a little quote. Yeah, it's just a colon.
Right there where the y is, the y equals cosine, and then is that a -1 or is that quotations?
This is a -1. So is it here as well. And sine inverse. So -1 means inverse of sine.
Thank you.
Okay.
Okay. Inverse.
And the top part is the requirement for something to be an inverse of a function. So, and I'll show you an example, like a basic one, so you can remember what inverse means. Okay, so I forgot to write the domain of x and y here, so I'm gonna have to tack it in the middle. So sorry about that. So -1, so for the sine, x is between -1 and 1, and y is between -pi/2 and pi/2. Over here, same thing for the x value. X is between -1 and 1, but the y is between 0 and pi. Over here is -infinity is for the x value, and the domain is going to be -infinity to infinity. So all real numbers. The y will be between -pi/2. Actually, we don't include it on the tangent, just less than, not equal to. Okay, sorry about that. And I'll give you a picture as to why. But here, let me give you the properties before we start. So here are definitions. The first part is a requirement for something to be an inverse. Then the definitions of sine, cosine, and tangent inverse. And here are the properties of inverse functions. Okay. To number 1, f inverse of f of x if I'm using it for sine, that would be sine inverse of sine x. They will cancel and leave you with the x, but only if x is between pi/2. Number 2, the other direction, f of f inverse is equal to sine of sine inverse of x. So that will equal to x when we have x between -1 and 1. So that's for the sine. And we'll talk about what this means in a moment. I'm just going to write down all the properties first. Cosine, so f inverse of f, got a parentheses there, is equal to cosine inverse of cosine, and that's equal to x. But only if x is between 0 and pi. Other way around, f of f inverse equals x. Oops, actually equals, that would be cosine of cosine inverse. So that equals x when x is between -1 and 1. All right, tangent, f inverse of f for the tangent would be tan inverse of tan. So they cancel out where x is between -pi/2. No, this one's not equal. It's just just less than. Last one. Oops, okay. F of f inverse for tangent would be tangent of tan inverse of x. That would equal to x, where that would be between, actually, yeah, for all x. Okay. So when you're doing the first few homework questions, you're going to have one of these situations, or maybe even secant, cosecant. But anyway, you have to know when they cancel or when it's undefined. So if the x that they give you is not within its required domain, right, they won't cancel. You'll probably say it does not exist, or there'll be like an option. They'll ask for the answer, or there'll be part B, like does not exist or something. Okay. So now let's talk about what the heck is an inverse, right? Just in case you forgot from college algebra.
Oh, sir, can you go back? I'm just finishing up.
Yeah,
I'm on
no rush, man.
tangent.
No
Sorry.
rush. Sorry, I should have asked first.
I'm good. Thank you.
Okay. Okay. So there's a couple of requirements for. Oops, where'd it go? You still see the graph? Okay. So for a function to have an inverse, it has to be, first of all, it has to be a function, of course, but also it can't fail the horizontal line test. So you see how right here, if I were to draw a line anywhere, really, let's say y equals 2, you see how it hits the red function twice? So because of that, we can't define an inverse without restricting the original question. But if we only look at it from this point to here, then the inverse will exist, and it will be the square root function. And we all remember that if we square root x squared, you get x, right? If you square a square root, you get x. So that's the definition of inverse. So that's what we're saying. Let me write it down for you so you can see what I'm talking about. Okay, so suppose f of x is equal to x squared, where x is greater than or equal to 0. So I'm restricting it on purpose. Okay. So f inverse, we should know that the opposite of squaring is square root. They're inverses of each other. So if I were to do f of f inverse, that would be the squared function outside and the root inside. So I'm plugging in the inverse, right, into the f, which is this, which gives me x, right? You see that? Excuse me. If I go the other way. That would be the square root of x squared, which gives me x. So the fact that I get x back in both directions, that proves that these are inverses of each other. That is the requirement. So if something is an inverse, they have to cancel out when you compose them together. Okay? Does that make sense? Do you remember from pre-cal or college algebra?
Yes.
So the idea now is apply inverse functions to sine, because so far what we've been doing, right? We have a trig function, we plug in an angle, and we get a value, right? So now what the inverse is going to do is you plug in a value, and you get an angle back. So it tells you like where is that location? What is the angle at that x value or y value, right? So for example, sine inverse of the number -1. Actually, let's do positive first. +1. Let me go open the circle. We're going to need it. Okay. All right, so here's the idea. So this is sine inverse of 1, right? So where is what sine is for y? So the question really is saying what angle gives me a sine value of 1?
90 degrees.
Yeah, 90 degrees or
Okay.
pi over 2, right? Either way. That makes sense? That's what this is asking. Now, if you were to use the definition that we wrote at the beginning, right? This is the same. Let me switch back here. This is the same as saying sine of pi over 2 is equal to 1, which is also true, right? That's what we're saying back here.
So that answer is 90 degrees?
For that one, yeah.
Okay.
Yeah, 90 or pi over 2. Where is it? Yeah, see how right here we can rewrite it? So sine y equals to sine inverse x is the same as x equals to sine y. So we switched it. They didn't ask us to switch it. I just want you to know that the definition is always there. Sine inverse of 1 equal to pi over 2, because that's the angle that gives me a y value of 1. That's what this is asking. Which angle gives you a y of 1? The other way to write it would be sine of pi over 2 gives me a y value of 1, right? That's the same question. It's just inverted. One moment. All right. Let me give you a visual of, well, first let me do one more example. Example 2. Let's say this is going to be sine inverse of -1. All right, where does this happen? So let's look at our circle. So the y value of -1 is technically at 3 pi over 2, right? But we said that inverse sine is not defined at 3 pi over 2. So let's look at the domain for the inverse sine. We said that the range needs to be negative pi over 2 to pi over 2, right? On the first definition for the y value. So meaning that sine inverse is only defined over here. It can't go all the way around to get here. It has to go negative. And if you're wondering why, well, let's look at the picture. So the notes I sent you. Remember how I told you that it needs to pass the horizontal line test in order for a inverse to exist. So you have to cut it off right here. You see how they cut this part off and then this other part where the blue's at. So if I cut that extra stuff, because the sine repeats itself forever, right? Then I can define an inverse function based on this small piece. So the domain will be negative pi over 2 to pi over 2. The range will be negative 1 to 1, but the inverse will be the opposite. Okay, so here is the inverse. So the inverse function of sine, you see how the x's and y's are swapped? Okay, so whenever the angles that I'm looking for need to be within here. I can't use anything else. And I can only plug in these x values. Like I can't plug in negative sine of 20. That would be undefined. It has to be between negative 1 and 1. That's as big as sine gets, right? So it doesn't make sense that you would plug in something bigger. All right, let's go look at the picture. Maybe this picture is better. So here's the original sine. So we have to cut it here and here in order to be able to create a inverse function. Here. You see how it doesn't go on forever? And the x values and y values have been switched. So negative 1 to and negative pi over 2. Over here, see how it's the opposite, right? That's what it means to be an inverse. When you have an inverse, the inputs become outputs and the outputs become inputs. It does the opposite, right? So you have one function that does something, then the inverse does the opposite. It undoes what the original did. That's the whole idea of inverse functions, okay? So if I want to undo an angle, right? Where's that stupid thing? Switch that. So originally I can plug in angles and get values, but if I want to know which value gives me which angle, then I use the inverse and I go backwards. It's just that the inverse have strict domains and ranges. Okay, so I would recommend these notes I just gave you, put them on a card when you're doing the homework or the exam. You say, okay, this x is outside, so it's undefined, or I need to somehow adjust and get like an equivalent angle, like a coterminal angle or something. Okay. All right, let's go back to the example. So sine of negative 1, sine inverse of negative 1 has to be negative pi over 2. Because I can't go to 3 pi over 2. Let's do another one. This time you tell me, where is sine inverse of square root 2 over 2? Where does that happen? Which angle? Right, the other way to ask this question is, which y value, or sorry, which angle gives me a y value of square root 2 over 2? Knowing that I'm restricted to the right half of the circle.
45 degrees.
Yeah, yeah, it has to be, right? Pi over 4 or 45. Does that make sense? If we look at our circle, the y value screw 2 over 2 only appears at the pi over 4 section. Okay. All right, let's do another one. So the first few homework problems will start something like this. So it's basically give you numbers. You got to give them the angles. Okay. And then they'll start doing these cancellations. The sine inverse of sine 0. Right? Remember we said that if it's written this way, they will cancel, leaving you with the argument. But the argument is required to be within a certain range of values or domain values. So let's look at the little formula I gave you. Currently, I have sine inverse outside. So if I have sine inverse of sine, x has to be between negative pi over 2 and pi over 2, right? And if it is, then you just write the value. Is 0 between here?
Yes.
Right? It's right in the middle, right? So since it's in that section, then I can simply say that yes, it is 0, because 0 is within negative pi over 2 to pi over 2.
How is it like between negative pi over 2? Like, can you show me on the unit circle?
Oh,
And-
how do I know it's in there?
Yeah, like how is 0 between that?
Let's look at it. Let's see here. So we're saying the range of values are all the way to pi over 2 and all the way to negative pi over 2. So right in the middle is a 0, right? 0 angle.
Okay.
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 And also another way you can think of it is saying, okay, if I go from negative 90 all the way to 90, is 0 within those values,
Okay, gotcha.
right?
Yeah.
So if it is, then you can say this. You can simply say these cancel and you get a 0. If it was not within this restriction, you would say it does not exist, or you'd have to correct it. Most likely, you just if you try to do it in a calculator too, you'll get an error. So I would probably just say it does not exist at that point, or undefined.
I'm sorry. When you say that means when you say that it means undefined, right?
Yeah, undefined, because it doesn't make sense, right? It has to be within that defined value, defined domain. Okay. Okay. Let's do another one. So sine inverse of sine of 100 degrees. So this is not necessarily a known value, but they may cancel if we can find an equivalent value. Let's see here. So you see how the y values are the same up here and up there? Pretty much same sign, right? So if I can't go beyond this point, I can use an angle that's in here to represent the same sine value. For example, if I went all the way to 120 and I notice the requirement, right? We said that it has to be between 90 and negative 90. 100 is too far, right? So we need to adjust this. So let's use the angles that we know to make it easier before we do this problem. So let's say it was 120. Like, well, that would be the same as what?
30?
Right, which one has the same y value over here?
60.
60, right?
Mhm.
So all we have to do is subtract from 180 degrees to find these angles. Okay, so 100 is too big. So an equivalent angle would be 180 minus 100, which is 80. So I can use this one. Switch back. I can say that this is the same as asking sine inverse of sine 80, which would be equal to 80. So we can technically find an equivalent angle for that one at least. But the original was not defined there, that you have to adjust. Now, if it's done the other way, there's not much you can do. So let's say cosine of cosine inverse of 1.2. This is too big, right? The requirement when a regular cosine is outside, in order to cancel the cosine inverse, we have to, here it is. X has to be between -1 and 1. And currently we have 1.2, right? It's too big. So this one is undefined because I can't adjust that because this is not an angle. You can do adjustments with angles because we've learned that there's equivalent angles, right? Using the complementary and what's it called? Shoot, word escapes me at the moment. So that would be undefined since 1.2 is outside the range of -1 to 1. Does that make sense? So it'll cancel and give you whatever's in here if it follows the rules. Okay.
It wasn't the domain?
Yeah, I always get dyslexic. Hold on, let me double check. For this guy, let me rephrase it. Cosine inverse was there we go. So the little x values range here, this x, okay? But technically, the x values of the inverse is a domain of the inverse, but it's also the range of the original. The range of the original is the domain of the inverse. So that's why I always get it, I always get it backwards. But to keep it simple, if 1.2 is outside the range of values, when you have the inverse cosine inside, then it's undefined. Okay, let's keep it simple.
Is that why the example above is different?
Yeah, this one's different because the inverse is outside. So here we can adjust because it's an angle.
Okay.
Okay. So you have a few of those. We gotta decide if it exists or if you can find out an equivalent angle, or sorry, if it's undefined or not. Either way. After that, you get into finding the inverse functions. All right. Let's see. I guess I'll turn this page here. You guys cool on this one? Any questions so far? You guys understand what the inverse does compared to the original? All right. Okay, before we get to the example, let me give you the steps as to how to find an inverse function. So this will be very similar to college algebra when you found an inverse function. Find the inverse function f inverse of the function f. Find the domain and range of f inverse. Okay. For the domain and range part, it helps to graph the one they give you. So we'll do this example here. F of x is equal to 4 sine x plus 3. So let's graph this first before we start. Okay. So the plus 3 shifted the graph upward, right? Remember how we talked about the vertical shifts, and then we talked about the amplitude. This 4 is going to spike the original. So instead of going from -1 to 1, it goes to -4 to 4, but then you move it up by 3. So it's been shifted from that -4 to 4. So the lowest y value and highest y value is -1 to 7. So the range is -1 to 7. The domain, well, goes on forever in the x direction, because domain is for x. Then you would say all real numbers, right? -infinity to infinity. So let me switch back here. We said -1 to -7, or 7, sorry, for the range. So -1 to 7, and -infinity to infinity for the domain. I'm using the interval notation. You guys remember what the brackets mean and the parentheses?
Say that again, the domain, what did you say you're calling those?
So this notation, you know how earlier I was writing it this way?
Oh, yes.
Shit, hold on. There's no equal to there.
And what is it called again? That little thing?
So this means that all the x values are between negative infinity to infinity. This one means the same thing. It's just a different type of notation. So this is called interval notation
Okay.
here. Parentheses mean you do not include the n values. Brackets mean you do. So -1 would be less than or equal to, meaning I actually get there. I never actually get to infinity, so it's an idea, not a number. That's why we have brackets here and not there. We also put parentheses on values that are undefined or are problem values. Like, for example, if a number caused division by 0, then you would not include it with a bracket. Okay? But do you see how we came up? Oops, that should be a y right here. Do you see how we came up with the domain and range by looking at the graph?
Yes.
Okay. So based on the definition of inverses from college algebra, the domain range of the inverse function will be the opposite. You'll just swap these, right? So here, let me show you. This guy right here. This will be swapped by this. So let me show you the steps. Okay. So step 1, change f of x into y. So you write y equals 4 sine x plus 3. Step 2, swap all x's and y's. So you get x equal to 4 sine y. Step 3, solve for y using inverse functions. Okay. So here we go. So before we use inverse, we gotta do some algebra. Subtract by 3, right? If you subtract both sides by 3, they'll cancel this guy, leaving you with this. Then the next step, you divide both sides by 4 to cancel this 4. So x minus 3 over 4 is equal to sine y. Now you introduce the sine inverse because you've isolated sine. So sine inverse of x minus 3 of 4 is equal to sine inverse of sine y. So these will cancel. So I solve for y this way. Kind of like when you would use ln for the exponential, do you remember? To solve for e, or when you have the e to the x, you have to bring ln. Step 4, change y into f inverse. So the answer will be f inverse of x equal to sine inverse of x minus 3 over 4. Domain, remember we said that the range of the original becomes the domain of the inverse. So it'll be -1 to 7. The range will be -infinity to infinity. Do any of those steps not make sense?
Can you explain the brackets differentiation?
Yeah, here, let me give you a picture. Yeah, I think I can find one. think I can make one in here. So let's see, -1 to 7. If I can do that two-dimensionally. No, that's 2D. I need it in 1D. Hold on, let me get a better picture. You know what? I could just draw you one. It's fine. So visually, -1 to 7 means you include this point. And you go all the way till 7 with the brackets. So everything in between would be the solution or the domain, including the endpoints. That's what the bracket is telling you. Now, if you had parentheses, you would say everything in between, but not the endpoints, would be the domain. So you'd have like holes right here. That makes sense? So like 6.99 is okay here, but not 7. Over here, 7 is cool. And so is 6.99.
Okay, thank you.
Yeah. Okay. You guys have any questions on that last problem? Does it make sense?
I had a question.
Yeah.
So when we got to the sine inverse x minus 3 equals sine inverse of sine y,
Here. Yeah.
what's the logic behind that? Because this basically seemed like, in layman's terms, it seems like a long way to go to just swap the domain and range from seeing this regularly.
So basically, we're solving for the inverse function. So the original, right, is this guy. So this is a regular sine function. What the question is asking you, find the inverse function, right? Originally, I gave you definitions of the original sine and sine inverse, but regular sine can be shifted or scaled. So the inverse function would also be scaled and shifted inversely. Let me give you a visual. If I can get it to work. So this type of stuff will allow you to solve for values inside the trig function, because you can't just, like, for example, if I gave you this, right, and said solve for x, right, you can't just divide by sine, right? So that's not a thing. So you have to cancel the sign using inverse. That's the whole idea. Okay, so here's the original. So the sine inverse would be there it is. So this guy, this purple line, is the inverse of the green function. Although you would have to restrict it here, from here to here, right? So once you restrict it, then you can define an inverse. So if I want to find values somewhere on this function, then I can use the inverse to solve for them.
So the inverse is from that first dot on the blue line to the second dot, but on the blue line.
Yeah, so we redefine the original sign, we cut it off here, and solve for the inverse, which is the purple one. So
sorry, I'm colorblind.
no, it's okay. No worries. There's some blue in there somewhere, right? but yeah, so just like the original, we cut it off like they did in the book, and we define an inverse function. It's just that now it's been transformed, right? that make sense, or
Kinda.
kind of here? Let me show you the original one more time, just in case. Right. So here's sine, goes on forever. So they slice it off, and only then can they create the inverse function. So they once they slice it, they're like, okay, so if I force the original sine right here, right, to be restricted on this interval, then I can define an inverse function, which is what they do here. So with that restriction, then an inverse exists, which looks like this. And it doesn't keep going because I had to restrict the original. And if I don't restrict it, then it can't be found. Okay. And visually, it looks like this here. See how they're opposites, right?
Yeah.
Kind of. And the whole purpose is just to be able to solve for values inside of a sine function. That's why we're doing this.
Okay. That's making sense now.
Like, let me see if I can find one. It might be later, though. Yeah, like this guy here. Like, if I gave you something like this, you could technically take the cosine of both sides to cancel the inverse if this was not on the circle, right? Since it's on the circle, you can find it. But if this was like, I don't know, 0.7, right? Then you'd have to introduce cosine on both sides to solve for this guy. Or let's see here. Let me find a better one. It might be the next section when they start doing that.
Girl, I'm still sore.
Oh, here we go. See how they're like, all right, here's an equation. We're actually solving something. We're not practicing or doing anything else. Solve for x, right? That's what they want. In order to do so, you would have to introduce sine. You'd have to first isolate sine inverse, right? See how they did that here? Once it's isolate, you'd introduce sine and sine on both sides, which would cancel this sine, leaving you with an x here. And then this value is on the circle, so you'd be done. Okay. But let's try one of those so you can show you what it means. But well, actually, before that, I need to make sure you're comfortable with these steps. So you guys are okay with the rest of the steps here? Finding the inverse function.
So the answer is the domain and range.
The answer is this guy, and then you'll have another part. Like part A will be this, part B will be this. On the homework question. Okay, let's do one more. No, let's do another one of those. Yeah. Okay. Let's say they give us this one. F of x is equal to -5 cosine. Oh, 1 second. Okay, 1 moment. Sorry. Okay. Sorry about that. All right, so -5 cosine 4x. Let's before we start, we should graph it and determine what is the domain and range values. And we can easily do it by looking at the picture. So we don't have to do anything crazy. All right. Okay, so here's the original, -5 cosine 4x. The highest value is 5, the lowest value is -5 because of the amplitude, right? So we can just write that the domain is -5 to 5, and we put brackets because the graph actually stops there. It doesn't stop right before. Oops, sorry, that's the range. There we go. Domain, though, is it just goes on forever. So when you're thinking of domain, you should look at the horizontal x values. Since it never stops, well, it's -infinity to -infinity. Which is usually the case for the sine and cosine functions. It's only the inverse functions that are kind of finite, right?
Thanks.
They're finite because of the horizontal rule, right?
Yeah, because we have to restrict it. We restrict the original and then create the inverse. So I technically have to say I have to restrict this guy in order to do so, right? All right, so where were we? Yeah. Okay, so let's start solving for the inverse function. So step 1, change y into f of x. Step 2, swap x and y. So x equals -5 cosine of 4y. Step 3, solve for y using inverse trig. Okay. So first thing is you need to isolate the trig function before you introduce inverse stuff. So we need to get rid of that 5. So we divide both sides by a -5. Which gives us -x/5 equal to cosine of 4y. So at this point, you introduce cosine inverse. So cosine inverse of x over, or -x/5 is equal to cosine inverse of cosine 4y. So these cancel, leaving you with cosine -1. And this pin running out. Let me try.
Could you lift the paper up just a bit?
Yeah. Sorry, I was checking. My pen ran out.
My pen ran out. I was like, damn, I'm like my professor.
Yours ran out too?
No, when I first started, my pen had run out of ink,
Oh, I see.
and I thought of you.
Yeah, I go through a lot of pens. Let's see. All right. See if it wants to write. Let me get another one. Well, it could be that this page is dirty. Hmm. One moment. Let's see what this guy writes. Cosine inverse of negative x over 5 is equal to 4y. So and you'll solve for y, right? Not 4y. So you'll have to divide both sides by 4. So then you'll end up with, put it over here. I think I'll just go to another page. It's just starting to look stupid. Cosine inverse of negative x over 5 over 4. I'm going to rewrite it. 4y over 4. There we go. So I have to go one extra step after I cancel the cosine. So 1/4, if you want to write it this way, you can, of negative x over 5 is equal to y. So step 4 is change it to f inverse. And you're done. So f inverse of x is equal to 1/4 cosine of negative 1, negative x over 5. Yeah, there we go. So then you swap the domain and ranges and you should be good. So this will be -1 to 7. Actually, that's not right. That was a different question. Yeah, I'm gonna double check everything. There's one thing. I mean, I said it, but I didn't write it. Remember how we said that we need to restrict the domain, right?
Restricted? I thought it was all real numbers.
No, it is. But in order to find the inverse, we have to assume, we have to force a restriction on the domain. So
I see. Yeah, because
yeah, because like, let's look at it, right? We found the answer. We'll go ahead and put it in here. We'll just call it y, I guess. We said it's 1/4 cosine inverse, cons of negative x over 5, right? And that doesn't go on forever, does it? The red one. So 5 and pi over 4, that is what we were saying over here. Where is it? Let me make this bigger because I can't see. All right. So this guy, the one we found, goes from -5 on the domain all the way to 5, which means that this range is going to be right here, right? -5 to 5. So these y's become the x's here. So the restriction on the domain would be 0 to pi 4s. So in the original question, I forgot to change it. Even though technically this is true, right? This is not wrong. The restriction would be, what do we say? -0 to pi over 4, right? Which means, yep.
That properties like inverse trig function thing you made.
Yes, that's a requirement for inverse to exist. It has to be restricted in order to make it 1-to-1. That's what the horizontal line was doing.
Then for this one, it's x should be between 0 and pi.
Yeah, 0 and so the range would be, sorry, hold on. The opposite, so -5 to 5 would be the domain here. And the range would be the opposite, so that is, what is that? Zero to pi 4s, right? There we go. But the algebra steps make sense, right? The domain range takes a little getting used to, I think. I highly recommend you graph it and look over the definition. Okay.
On the range, will the negative always go first? Like on the other side of the page, the range was -5, comma 5. Is the negative always first?
Yeah, the smallest or most negative goes first.
Okay.
Okay.
I don't get how we got the range though.
The range?
It's by graphing that I would know.
One more time, sorry.
Just by graphing it, then I would.
Yeah, if you graph it, you'll so it helps to understand the original first. So let me put this back on real quick. Just one more time because it is a little difficult the first time around. So let me hide these for now. So remember how we had the original and the and the inverse. So I have to restrict the original, even though the domain goes on forever. I have to cut it off here. Once I cut it here, then it passes the horizontal line test. It doesn't hit it more than once. Once that's established, that means that I've created a 1-to-1 function of the sign. Because back in college algebra, it had to be 1-to-1. In other words, it has to pass the horizontal line test for an inverse to exist. So you restrict the original, and then these values swap and become the range and domain of this one. So you see this? So this blue one goes from, for the domain, negative pi over 2 to pi over 2. So that becomes the range of the green one, which is the pi over 2 to negative pi over 2 here for the y values. You see that? So you swap those. So all you got to do is restrict the original. So going back to the one we just did, right, it looks a little harder. So you do the same thing though. You just restrict it the same points. It's just a scaled function. It's still a sine or a cosine. And then you use these values here. So the domain would be 0. I'm sorry, 0 pi over 4 would be the domain of the black one, which becomes the range of the new one we find, the inverse. And then this range, negative 5 to 5, becomes the domain of the inverse of this guy. Okay.
Uh-huh.
So it's just that first step. You gotta just restrict it, or remember there has to be one. You can't just leave it. Like originally, I think I made a mistake earlier. Originally, I said to swap them, but it is technically true, but the swap is assuming that I've already restricted, and I didn't. So you would have to restrict this guy as well. So this
So-
range would be wrong, actually.
So we're not restricting the amplitude at all on a function. It's the x value that gets restricted.
Yeah, you restrict the domain, which in turn restricts the range of the inverse. Okay. Do you have any other questions on 8.1? I'm gonna see if I can find another problem for you. So that's pretty much all the homework questions you're gonna see, except this example 11. I'm gonna go ahead and do it. Final example in the notes I sent you that we talked about. Solve the equation.
Jack, we can't see it.
Oops, sorry. Three sine inverse of x equal to pi. So solve for x is the question. So you have to isolate the inverse, or the trig function, first. So you divide both sides by 3. Which cancels this 3. Then you introduce sine on both sides. So sine inverse, now that we know that we can do this with the definitions, we will cancel, leaving x equal to sine of pi over 3, which we know is what? What's the y value at pi over 3?
Square root of 3 over 2.
Yeah. And that's what they do here. They just don't show as many steps, right? So in their case, they divided by 3 and they use the definition, which is also appropriate. But I think it makes more sense to think of it as introducing a sine function in order to cancel. But if you want, you could think of it this way. You say, you know what? The definition says x equal to sine y means there's a y equal to sine inverse of that x. So you could go this route. It's up to you, though. I like this way better, but I don't care how you do it, as long as you get there and it makes sense. Right,
Hey, so I
Uh-huh.
so I get kind of confused with like the words, like when you say present. So are you're adding like something, or are you like? Because what I thought of it was like when you wanted to do like when you wanted to cancel something out, you either like let's say you wanted to cancel 3, you cancel it out with a -3, right?
Yeah,
Is that like kind of like the same?
I think. I mean, kind of. I think a better way would be to think of it as square rooting both sides when you have like an x squared or something,
Okay, right, yeah. That
because
makes
that's introducing a function on both sides. So that's what we're doing here. We're introducing a function to undo this, just like we're undoing a square. Or if you had a square root, we would square both sides to undo the square root. That's what
okay.
this is doing. And that the fact that it works is because of the idea of inverse functions.
That makes sense.
You guys have any more questions on 8.1? I mean, the inverse idea is, I mean, I think it takes a minute to digest, but
You know what? I think the partial fractions were harder than this. Like, this is hard either way. I'm just saying the partial fractions were harder.
No way, I like that instead of this.
Right, yeah.
yeah, I mean, it's whatever you guys like, man. This is how it is. But I think the partial fractions had a lot more algebra, but this has a lot more theory and definitions behind it. So until you understand the definitions and the graphs, then this will make more sense. But if you still kind of trying to grasp that part, then this may seem more difficult.
So on the test, what you'll be looking for is, do we follow all the steps to cancel it out and solve for it?
Yeah, that's all I want to see is, did you solve for x appropriately? Or did you find the inverse function appropriately? And did you give me the domain and range? So that's like the big picture for this section. Can you give me the angle? Can you give me the x value? And can you find the inverse function? And do you know what the domain and ranges are? That's pretty much it.
Jack, how's our test coming along? Do we have like unexpected?
I have not looked at it. I'm gonna do it during spring break,
Oh, okay.
but tomorrow I have pretty much a lot of free time, so I'll probably start tomorrow.
When is spring break?
Next week starts Saturday, I guess. Maybe Sunday. I don't know if you have a Saturday class, but
Oh, wow. Okay. Can you, I lost connection for a little bit. So can you please, if you can, remember to post the video tonight so I can watch it again tomorrow?
yeah,
I
I'll
missed-
post it right after.
Okay.
I didn't miss last. Well, last time we didn't do anything.
No, you didn't. I'm going to have to go over it because I lost connection for a
Oh,
little
that's
bit.
fine. That's fine. Understood. Okay, so 8.2 is the same nonsense, except it's secant, cosecant, cotangent. So it's going to be the same ideas. It's just you have three different functions with different domains and ranges. So let's go ahead and start unless you have questions about the original three functions. There we go. All right, so I'm gonna give the definitions first. Let's see, where is it? Oh yeah, these are weird. Okay. Y is equal to secant inverse of x if and only if x is equal to secant y, where the absolute value of x is greater than or equal to 1. And 0, excuse me, 0 is between, y is between 0 and pi. Also, y cannot be pi over 2 because you'll have division by 0. Okay, cosecant inverse. So y equals cosecant inverse if and only if So this definition right here is basically creating a restriction for the original functions, right? For the original secant, cosecant, etc. So this is equal to x equals cosecant of y, where absolute value of x is greater than or equal to 1. And negative pi over 2. And y is between negative pi over 2 to pi over 2. Y cannot be 0. Okay, last one, cotangent. So this is y is equal to cotangent inverse of x if and only if x is equal to cotangent y, where negative x, or x is between negative infinity and infinity. And y is between 0 and pi, but not equal to. All right, so here's the three functions for 8.2. So it'll start off similar to how the other one started, but the hard ones are going to be these here. Let's start with the hard stuff. So find the exact value of the following. Cosine of sine inverse of square root 3 over 2. Actually, I'm going to write it over here because that looks weird. Cosine of sine inverse of square root 3 over 2. All right. So it helps to let theta. So I guess let's think of it this way. We know that the original cosine of theta is equal to adjacent over hypotenuse, right? And we're given a cosine of some theta. The theta looks super weird, but this is some theta, right, inside. So we're going to say let theta equal to sine inverse of square root 3 over 2. So that means that I can use this idea now. It's more clear. So this implies that there exists an angle that would give you square root 3 over 2, right? Using the definition. Remember how we said if theta is equal to sine inverse of some value, then that value would be equal to sine of theta. So that was at the beginning of 8.1 over here. Here, let me give you the book. Where is it? Yeah. If you're wondering where the hell that came from, right? So right here. So y is equal to sine inverse of x. If and only if x is equal to sine y. So I swapped this guy into this. That's what we did on the paper. So we had theta equal to sine inverse of some value. So it's like saying y equals sine inverse of x. That means that x is equal to sine of y. Using the definition. Does that make sense?
When you explain it, yes.
So I'm going to put the implication arrow double implication. So if you have this, you can change it to this. That's what I'm saying. Right. So I'm going to do it one more time. So I have this. Maybe it makes more sense with the definition right above it. That would mean that there exists a square root 3 over 2 that is equal to sine of theta. So this right here is the definition being applied. That's why I got this. Okay. Okay, so anyway, the original question was what? Cosine of sine inverse, right? So we will use sine theta equal to square root 3 over 2 to create a triangle. So here's theta, opposite over hypotenuse. This will be, when you do Pythagorean, it'll be 1. Cosine of sine inverse of square root 3 over 2 is asking what is cosine of theta given sine inverse of square root 3 over 2. Right, so this gave me this. So cosine would be what?
Hypotenuse over Jason.
Close. It'd be Jason over hypotenuse, right?
Okay.
Okay, so the question they're asking, like, I think I got it a little messy there.
What is that sentence above the long arrow?
So cosine of sine inverse of square root 3 over 2 is asking this question here. What is cosine theta given that sine inverse of square root 3 over 2? So basically this original question, let me open the book for you. I should. Where is it? Oh, I guess I don't have that one in particular.
So it's basically just what is the cosine of 60 degrees, right?
Yes, yes, that's another way to think about it. But I do want you to use the triangle because I know right now you can kind of look at this, right, and say, well, I know this is going to be 60 degrees, right? Probably. But pretty soon this will be a variable. So if I change that to u instead of a number, then you have to use this. That makes sense?
So the answer is 60 degrees?
The answer is this. What is cosine? It's 1/2.
Okay.
I can't see it.
This thing's in my way. Hold on a second. There we go. So when you use the definition of sine and when you have for the inside part here, then build the triangle and find the cosine. That's all you got to do. Let's do another one because I know that that's kind of weird. But before we move on, got any questions on this first question here? First example. All right, 1 second. Let's go ahead and move the number 2. All right, so same problem. It's different functions. So given, actually, here, let's go ahead and write it. Okay. So they're asking, what is tangent of cosine inverse of 1/2? So you build a triangle with the inside part, and then you give tangent. So you start with this. So you start with the inside, and you say let theta equal cosine inverse of 1/2. Then you use the inverse sorry, the inverse would be cosine theta is equal to 1/2. So that's the definition, right? The definition says that this exists only if this is true. So you can convert back and forward. Once you have this, you can create the triangle, right? All right, so cosine theta equal to 1/2 means adjacent over hypotenuse, correct? Solve for Pythagorean theorem. So a squared plus b squared equals c squared. That means that a squared plus 1 squared equals 2 squared. So a would be equal to, a squared would be equal to 4 minus 1. So a is square root 3. Okay, so now we have all 3 sides. So what is tangent, right? So tangent of cosine inverse of 1/2 is equal to opposite over adjacent. Okay, does that make sense? Just opposite over adjacent, right, over 1.
because after you solve for the cosine on the top, you're using the adjacent over hypothesis, but then on the second line, you're using the tangent. So then we're using opposite over adjacent.
Yeah. So we have to remember what is tangent of theta? Well, that's opposite over adjacent, which is equal to
Okay.
Does that make sense?
Yes.
This one seems a little easier for some reason, this one.
Yeah, I think once you go through it once, it starts to make a little sense. So you just go back to the other one too, right? You use the inside to build triangle. Once you use the definition to change it, such we did here, build the triangle, and then give it cosine. Because the original question was, what is cosine given this?
Okay.
Okay. So the first few examples, or first problems on the homework are not too bad. And then they decide to get rid of the numbers.
So secant, cosecant, and cotangent, kind of like the same thing to do.
Yeah,
With
you just
this-
need to remember how they're defined in terms of triangles.
Okay, easy.
So, but yeah, the process will be the same. Is that what you're asking?
Yes. Yeah.
Write the trig expression as an algebraic expression of u. Okay, so this time they're saying, all right, what is cosecant of cosine inverse of u? So let theta equal to cosine inverse of u. The definition says that that is equal to some u would be equal to cosine of theta. So build your triangle. So cosine is opposite over adjacent. So you put, adjacent over hypotenuse. So there's the u. And there's always an invisible 1. So you put a 1 here. So solve for the missing side. So we got a squared plus b squared equals c squared. We're looking for a, b is u, c is 1. So a squared would be equal to 1 minus u squared. So a is the square root 1 minus u squared. So what is cosecant? Right, that's sine, right? So it'd be hypotenuse over opposite. Is that correct?
Yes. Yes, it is. Is it 1 minus u or 1 minus u squared?
1 minus u squared. So
Is there always an invisible one because the radius on the unit circle is 1? Is that why?
no, just any number or term you can put a 1 underneath.
You could
Like,
just always, okay.
yeah, like the number 5 is equal to 5 over 1. Still
So,
true.
okay.
All right. So the answer for cosecant would be hypotenuse over opposite, right? Wait, that's not opposite. Opposite is the square root of 1 minus u squared. Then you can rationalize by multiplying the top and bottom by 1 minus u squared. So that will give us square root of 1 minus u over 1 minus u squared. So this is the more proper answer, but this one would be technically right, though they may ask you to rationalize. Anyway, but the main idea makes sense, right? You take the inside, if it's an inverse, you apply the definition, build a triangle, and find the outside cosecant.
For the like the last part, it's not like 1 square root 1 minus u squared.
Yeah, 1 times this is just that. So you don't have to put the 1, but it's
Okay.
technically there.
Okay, okay.
You could put 20 ones in front, and it'll still be the same, right?
But if there was like a 2, 2 would have to be there.
Yeah, if it was a 2, then I would write the 2. Correct.
Okay.
All right, we're pretty much out of time, but that's 8.1 and 8.2. Try to go over it, read the definitions, try to get a feel for the graphs. That should help the homework problems. Okay, and then when I see you again, we can answer some questions if you get stuck or something.
Okay, thank you. Have a good night, everybody.
Right, have a
Thanks,
good night,
everyone.
guys.
Have a good one.
Yeah.